Ladies and gentlemen, welcome to the Ryan the Ride Mechanic channel. How the heck are you doing today? Listen, on today's video, I wanted to talk about one thing, and that's a top spin. Everyone likes a top spin. If you haven't ridden a top spin, I'm sorry, you should go ride a top spin. They are quite awesome. But I wanted to talk about what makes them tick, which is why most of you are here. So let's figure it out.
Now get ready. Here we go.
First of all, if you haven't, make sure you like and subscribe. That way you can get more videos just like this. And leave a comment downstairs. I do appreciate it, and I'll get back to you as soon as I can. And let's get into the video. All right, so the top spin made by HUSS, which I always say HUSS, but it's actually pronounced HUSS. Masha Fabriken. Probably murdered that one, sorry. But anyways, HUSS, man, this is going to be tough. Started out as a... from my understanding, started out as a tank manufacturer, which is pretty common when you look at their rides, because their rides are built really stout. They're heavy duty. Nothing runs like a HUSS. Those things are quite incredible. But today's model we're going to talk about is a top spin, and so let's talk about the general configuration of a top spin. There is two towers that host one arm per tower. At the bottom of each arm is a gondola that typically seats about 40 people, and there is a connection bar that crosses between the two towers for stabilization and safety. So that being said, there are multiple models of the top spin available out there. There's the classic top spin. There is a inverted top spin up there where you got no floor on it, where the seats are back to back on it. So there's plenty of different ways this can happen, but I'm going to go over the original version, the main top spin that a lot of people know. And you should know that the concepts and parts and pieces on these pretty much translate through all of them. The configuration might be slightly different, but if you know one, you pretty much know the rest of them. Okay, so let's start at the groundwork. What do we need for groundwork, concrete, things like that? Well, one of the things that the top spins commonly had for full park installs, because there are traveling models for these as well, but full parks like to put fountains up front, and it was actually part of the ride package was to put a fountain up there, and that was an interactive water element that actually came very close, in some cases actually contacted the gondola. The one that I worked on, we were never able to get the fountain to work properly. When I showed up there, the fountain was off. It wasn't being used at all. I got the fountain running at least, but at a static level. But the way it's supposed to work is that the water streams in front of the gondola are supposed to get higher and lower as the gondola goes around. So on those things, you have a cement package that goes up to both sides typically, and it's elevated because the entry points onto and off of the gondola are at the very sides of it. Some rides have it set up to where you can go through one way, some have it in and out the same direction. But basically, the other thing to know is that when all the restraints are up, your lower restraints are up on there, those lower restraints actually form the barricade that allow you to walk down there without falling off the front of the gondola. So very necessary, you can't tag those lower restraints out on the front row. Next, we'll move into tower construction. So on the sides, the left and the right side, there are two towers that stick up vertically. They're big flat looking towers that sit there, and they are the support structure for the ride, one on the left, one on the right. Now, up on the tower, you have these two modular looking hang-offs that sit out there, and what these are is they're hanging from the tower. There are two motors with, just above it, two gearboxes that both translate 90 degrees to a ring gear and pinion, ring and pinion that sit off the side. The giant ring gear, which is a geared slewing ring, and then two pinions that sit on the outer corners of that. Looks kind of like an upside down Mickey Mouse symbol if you looked at the side view of it. Inside that geared slewing ring, which the support arms are mounted to, on the left side, if you're looking at it, ours anyway, I'm sure they're interchangeable. On the left side, we had there was two things. There was the pneumatic air line that came through that side, and that passed through. But inside around that there was the encoder, and the encoder was the arm encoder, would tell the controller exactly where the arm was. It was thousands of pulses as it went around, but it knew the degree, so it would start counting as it went up, and it knew exactly where the arm was. And there was a way to reset and home the encoder to where it told you that 0 was perfectly straight down. So on the left side was the air coming out, air pressure from an air compressor, and then there was the encoder that read arm position. On the right side, we had the same thing. It was a geared slewing ring because the right side tower wasn't identical of the left side. It had the tower with 2 motors, 2 gearboxes, and the geared slewing ring in the center with 2 pinions on the outside of that connecting the gearboxes. But then in the center of that one, it had an electrical slip ring assembly, and that was to transmit power to and from the gondola. Now, power consumption stuff down there, we'll get into it briefly, but there's really not much happening down there. You had a hydraulic package to run, which needed 3-phase power, so that was 3 slip rings. You had power to the gondola for controls, that was 1 wire. And then you had the return power for that. You had Bose close. The upper closed position and the lower closed position. If I had that right, about 7, 8 slip rings, somewhere right around there. Yeah, that sounds about right. About 8 slip rings in there. And then, and the lighting package. I think another 3 slip rings for the lighting package. Because on the front of the gondola, a lot of times they'd put these big spotlights in on the top of it as well. Because if there's one thing HUSS did really good was they did ride lighting really well. Big lights, you could really see them at nighttime when they ran. They looked really good though. And then, so that was, you had the slip ring package on that right hand side and the slewing ring and all that other stuff. Okay, so then to build it from there, we're going to add the arm onto each side. The left side just got a solid arm. It was one big chunk of steel. Hollow, of course. But it was one big chunk of steel that would mount to that. And then at the very top of that arm, there is a big set of counterweights up there. They just look like big round discs. They were just solid plates of steel that were added on to help counterweight the gondola. The right side had a similar one, but the arm was shorter, kind of. It was shorter from one side to the top where the counterweights are, but then from the bottom there was a giant pin that ran through it. The pin is a hinge point for that arm. The left arm was solid. There was no hinge at all to it. And the right side had a pin on it with another bottom part of the arm that actually extended down to where the gondola was. So now we have the towers, motors, and the 2 arms with counterweights sitting there. Now, to connect the arms out of safety, there is a drive shaft that runs from the left side to the right side, or depending on how you think about it, from the right side to the left side. Doesn't really matter. The drive shaft is just like that of a car. If you think about what a car drive shaft looks like, it looks exactly the same as that. So you have a giant tubular metal shaft that runs between the two. On the inside of that shaft, you had these big universal joints, just like a drive shaft from a car. It's got these big T universal joints that allowed both sides to essentially move like this, and that was to allow for slop on either side. And then those guys were mounted to plates onto the side that had also big rubber flex couplings on the inside of them. The flex couplings would allow torsion to be absorbed into their left and right, but not much. The assemblies up there were really stout and rigid. Like they didn't want to flex much, but they also didn't want to break the drive shaft in the center apart, so there was some rubber coupling to allow mismatch in the 2 arms so they could essentially walk out there, because it's kind of necessary for these rides. So drive shaft, U-joints, flex couplings, and that also helps support those 2 towers from moving left to right or doing anything else up there. Now, on the bottom side of those arms was the gondola. So we are going to do two things. We have on the inside of those arms, there's a big circular cutout because there were giant circular brakes, one on each side. It looks like a drum brake off of a car. You can imagine that, but about 4 feet in diameter, roughly. I mean, 1.5 meters, somewhere right around there. Really big brakes sitting out there. Those were pneumatically applied. So the air line that was coming in from the other side of the ride would feed that brake package and apply those drum brakes like that. And then inside of that, the other side, the receiving side of that drum brake, was applied to the internal of the slewing ring. The slewing ring was mounted on the side. One part was mounted to the arm itself. The outside was mounted to the arm itself. The inside was mounted to the gondola. And the other side of that was also had the drum on it. So you had outer mounted to the arm, and the inside was mounted to the gondola with the brake on it. And then on the inside of that slewing ring, it was transmitting power from the top to the bottom on one side. So it had another set of slip rings down there. And then on the outside of the other one, it also had the same pneumatic coupler on that side that will allow air pressure to transfer into the gondola itself. So same setup on the other side, air coupler, but you had the slip ring, you had the slewing ring with the brake assembly on it as well. So they're identical on both sides, just power and air, depending on how you want to think about it. Those guys were mounted to the support structure of the gondola. The gondola had these giant cones on the inside. So you think about it, they were like big pins sticking into the side of the gondola, and they had this tapered cone that the pin received into inside there. And then there was some safeties to keep that assembly together so they didn't just come apart in there. Those cone bushings were sitting inside there to help absorb flex and vibration and all sorts of other stuff. And then the bushing would sit inside just the arm on the side of the gondola, and then you had the gondola itself. Okay, the big unit that you would sit on in between the two arms. So that guy was its own package. You had pneumatic, electric, and hydraulic on there. So let's start with, why don't we start with the hydraulics first? Your restraints, which were very simple, over-the-shoulder restraints that came down first with a lap bar, a T, that would meet on the outside of it. So the restraint assembly was very simple. It had one hydraulic cylinder in the back, and it would push the restraint down and close it. Every day we had to take a special test device through there and put the test device down, close the restraints, turn the power off, and we push it down, and this thing would just sit there and push on the restraints and try to open them back up. It was checking for hydraulic bleeding in that restraint cylinder. So what would happen is that if the restraint cylinder opened more than 10 millimeters, or 1 centimeter, if it opened more than 10 millimeters during that testing period of 8 minutes, I think it was, then that seat had to be tagged out and it couldn't operate. But what the hydraulics package would do is it would create hydraulic pressure and put it out to all the cylinders on the back of the coach, on the back of the gondola. So most of the rides had 40 restraints on them, so you'd have 40 upper cylinders and then 40 lower cylinders to close the lower lap bars. So that was the hydraulic package that sat off over there. And then the way the restraints were set up is that it would first, you sit down and the operator would hit close restraints. So all the restraints would start to close times all 40. All 40 would start to come down. The hydraulic system was simply just pushing pressure into those restraints to keep them to close down. Once they started coming down and actually started making contact with the people and started pushing on them, the hydraulic pressure was set very low, but it was set to where it would gently basically just push on you and make sure you were seated back in your seat and just push down onto your body so you didn't go anywhere. And then in the back, there's a limit switch, mechanical limit switch, that once those restraints were all closed, 1 through 40 were closed, then it would tell the lower restraint, the T-bar, to come down. Now the T-bar was there mainly as the secondary to the restraint itself, because most rides we use 2 hydraulic cylinders to hold that restraint closed. Actually, I'm sure in their inverted ones, that's what they probably use. 2 hydraulic cylinders to keep those shoulder restraints closed. But for the original models, they didn't use that. They only used a 1. So as a safety, they put that T-bar out there in front of you. And when that T-bar came down, it would come down, 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 and then it would push against that restraint. The 2 actually met up together and physically pushed on each other. So now you had your restraint, which was being reinforced with that T-bar. If you've ever ridden on one of the rides, it is like one of the safest feeling rides you'll ever sit in, because once you're in there and the restraint's down on top of you and the T-bar is pushing on you, it's like you don't care at that point. It's like, I'm not going anywhere in this thing. You feel really safe on those particular rides. So we'll move on to the pneumatic side of it, because while those T-bars were closing down, they had these cylinders that were open at the bottom. Now what the cylinders would do is they would hold a mechanical ratchet open and allow those T-bars to close down. So if you've ever been on one of those rides, you hear when they close the restraints, you'll hear the hydraulic motor start to wind up as it starts putting pressure to close the restraints. And then you will also hear on the way down, when the lap bars start to close, you'll hear them start to ratchet. You'll go clunk, 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 clunk as they come down.
They're fine!
And what that is that the hydraulic cylinder is expanding, bringing that T-bar down, but then there is mechanical latches, just like a restraint on an older ride, there's teeth on the inside that are ratcheting down as that guy is closing. And then the pneumatic cylinders sit there. Those are needed to open the entire system back up. Okay? So you have hydraulics backed up with mechanical ratchets that need pneumatic to open, and the whole thing works off of electric, of course. And then the electrics in there, they are for your 40 seats are daisy chained both top and bottom in 10 seat increments. So what they go is they go seats 1 through 10, uppers closed. And they keep doing that all the way through to the top to bottom until you get to the 40 restraints. And then on the bottom side, there are 40 limit switches also that say that T-bar is down close enough. If you've ever sit on there where they open and close the restraints a bunch of times, that's typically a big person sitting in there where they might get the lower signal that the upper restraint has closed enough, and it says, yep, and they start to bring those lower bars down, and then that lower bar doesn't go far enough. It doesn't make the limit switch. So the ride can't effectively say that seat is locked. Now, the operator doesn't know because the ride's broken up into 10 seat segments. So all they know is that when they're staring at a full gondola of people, they could just look at their little feedback panel on there, which is just a bunch of lights. And it will say the lights for seats number 11 through 20 is out. And they kind of look down where seats number 11 through 20 are, and they just kind of go like, all right. If they don't see someone really big where it's obvious the restraint's having issue holding that person in, they kind of are just forced to open and close the restraints a couple more times to see if maybe someone was sitting really forward or like kind of slouching in the seat, and maybe you might actually hear them say, hey, well, sit upright. Everyone, I'm going to open the restraint and then kind of like sit upright and sit up straight and then close it down. A lot of times that fixes the problem. But it's basically the lower limit switch isn't made. And then once they're done there, they say, okay, and they go back and they go up there and they turn a key switch on and they hit ride start at that point. And then the ride's off and running. All right, so when they come back from the ride, we'll still talk about restraint operations. The operator goes up to the gondola, and these things are typically guarded. There's typically another key or something up there needed to press these buttons. That way people can't just get at them and know they're not active while the ride is running. As soon as they hit ride start, it takes away the power and all that stuff from the restraint control. so it can't accidentally operate with the ride in operation. Like all that stuff is interrupted. It's all safety. Don't worry about that part. But they go up there, typically put in a key or something, and when they hit open, you'll hear a quick hiss of air, which is tsh. That's all the cylinders underneath on all 40 restraints. All of them have now retracted the cylinders back in and opened up that mechanical latch. And then once it gives it a little bit of time to do that, and then it starts hydraulically opening the lowers and the uppers at the same time. They both come open at the same time. Lowers come away from you, uppers come up, and then everyone's free to get up and exit while that's going on. Okay, so let's move into operation. There is basically two operational modes, well, three actually. There's manual mode, automatic mode, and then recovery mode. So let's go over manual mode real quick. The one I was working with, and I say this because I have heard other people talk about their models, they had different functions on them. Not sure if it was something that Park added, which I'd be like, wow, that's a great function. Ours should have had that. Or if it was something that maybe HUSS added in on top of that. I don't know which way that was. So the way ours was, we had a manual mode. And what could we do in there? We could put the key in, turn on manual, and then there was a little knob on there that we could tell the motors to go all clockwise or all counterclockwise and get the gondola to start moving. And then we could turn the speed up and down. So you can get it to go faster forward or faster backwards. So this is typically needed on these type of rides to do overspeed tests, because the drives in manual mode typically have safeties removed in that case. So what you do is you put it into an overspeed test and you say, okay, I'm going to go counterclockwise, but I'm going to go up to speed number 9, right? Because it doesn't go to 11. It doesn't go to 11.
These go to 11.
So you go up to speed number 9, and then the gondola picks up and it starts moving really fast, and it may take a revolution or two, but eventually it gets up to speed 9, and the ride goes crap and shuts it off, and it says it's going too fast. That's a successful overspeed test. You could do it the other direction too, but if it picks up in one, it'll pick up in the other one. And then in manual mode, we typically use that for recovery. In the morning time, you could turn it on and you could say, hey, just let it, just bring it up to speed 4 and just let it run for a while just to get the motors nice and warm before you start putting it through its paces. But realistically, when we go out there, it's because the ride is faulted. The gondola's in one side or the other, and we have to go out there and basically turn it to manual mode and bring the gondola back down to its loading position. So typically in manual mode, you just go out there, turn on, and then bring the gondola back down. Now, in recovery mode, manual mode goes right into recovery mode, because in recovery mode, you don't have that ability sometimes. When a big guest is on there or something happens and one of the restraints registers as open during the ride, it kills the ride, it sends it into an e-stop. And then sometimes the act of doing that makes that restraint register closed again. If it's somebody right on the edge, it can go through and do something and it says open and it goes crap, e-stop. And then when those people settle back down into their seats a little bit, it goes, oh, I'm closed again, I'm good. We can go out, manual mode on, bring the gondola down, no big deal. Sometimes we go out there and that condition is still in that way. We don't really know because it doesn't really say, but the Bose, I believe the Bose open light, or the Bose closed light, is off, it's dark. We do a lamp test, it like turns on, take a finger off lamp test, it's dark. It's like, okay, it thinks the restraints are open. So we do our best, we go back there and we look. It doesn't look like anybody's restraints are open. It's like, okay, we try a couple things, e-stop, power it off and back on, try to reset it, get that circuit to latch back again, still won't do it. At that point, we have to go into recovery mode. We go up into the control system up there, and we say, okay, let's go to, I believe it was mode 2, I think it was emergency recovery. And then you go out there, and on the bottom of the control cabinet, there's a bunch of big DC batteries. They look like car batteries. Just there's a bunch of them down there. And then you switch it into mode 2 with the power off. And then those DC batteries connect directly to the DC motors. And then you go back down to the ride, and there's a pendant, which is an up and a down arrow. and then you would bring the gondola one way or the other, and it was a slow process, but you'd slowly bring the gondola back down to its home position, what looked like the home position, because the ride's not on at this point. The ride is completely powered off at that point. So you bring the gondola back down basically where to like your loading and unloading pathways lined up on the sides. Okay, that looks good. And then you would stop that, and then you'd have to go over, and then on the side you'd have to bring this special little power cable, plug it into the back of the gondola, and that would deliver power to the restraint system. What is that? Well, that is to open it up and let air pressure go through to the bottom teeth. Remember the ones that were locked shut on that lower? You have to open the valve up to let air pressure go through and tell all those cylinders to retract to let the lowers open. So they all retract, and then you take this little tiny manual handle and you stick it in there and you turn some valves in the back. You close one, open the other one up, and then just like you're lifting a floor jack on a car, you basically start pumping this hydraulic handle. And it takes a very long time to do. It takes a good 5-6 minutes to do. But you sit there and pump hydraulic pressure up, and you pump it and you pump it. The entire time the restraints are very slowly just lifting little couple millimeters at a time every time you pump it. And they're very slowly lifting up and up and up and up. If the other person right there has to hold a little knob. And the reason why they have to hold the knob is because that little knob is allowing the power to go through and not only releasing the pneumatic air cylinders that's telling it to leave the restraints unlocked, but it's also supplying power to the valve that allows the hydraulic fluid to go into the restraint assembly. So we've done this several times where we pumped it about halfway open, and then the person did something and accidentally let go of that little knob, or I believe it was a key on ours. Can't remember if it was a knob or a key, honestly. But anyways, they let go of that little guy, and then we heard the restraints go, and then everything just went clunk, back shut again. It was like, and we had to restart the process again. Okay, turn the key, turn the knob, and start pumping it back up again. And it's a lot of like arm work, just going back and forth on those things. So eventually, after a while, you pump everything open, and then you get everybody off the ride, and then you can reset and investigate as to why that might have happened. But before that, you'd look and say, okay, which one is it? It's like, oh, there we go. It's, 11 through 20. It's like, okay, then you at least know your problem is somewhere there in seats number 11 through 20, because daisy chains aren't very specific when it comes to that sort of thing. Some parks had a button on the panel to lock the brakes on the gondola. So on ours, when we put it in manual mode and started rotating it, all the brakes would unlock, and the gondola would pretty much just stay level while it was rotating around. If you got the speed going really fast, the gondola would start rocking a lot as it kept going around. But about a good rock is about all you can do. You couldn't really get it to flip on its own. Other parks that I know they've had their drives tuned really good, and they were still very aggressive, the operators were telling me, the mechanics were telling me actually, that they could, in manual mode, get theirs to flip just by oscillating the gondola a bunch, and just keep going up and down with the arm until the gondola was going back and forth, and then they start going over with it and back and forth, and they could actually get the gondola to flip over a couple times as they did it. But ours couldn't do that. Some parks installed the brake button there to hold it, which is what the ride does during its program cycle. We'll go back to automatic mode. Automatic mode was typically, the operator had a selector switch there. They had 9 programs to choose from. They could stick the key in and change it between all these different programs there. They all did different things. The ride was programmed to do different things in each one of them. On ours, and I can only speak for ours on this one, on ours, program number 4 was called the Top Spin program. It was the only one that did the top spin. None of the other programs did it. They brought the gondola up, they locked the gondola in certain positions, and they did things, but none of them actually did the flip of the top spin. So ours, only program number 4, was the only one that did that. Everything kind of looked like a waste. It wasn't very fun. We tried a lot of stuff, but we always left ours on program number 4 because of that top spin feature. That was the best way to do it. So let's go into the control cabinet in the back. And I'll come back and touch on that top spin feature more. So don't worry, it's complex. So in the control cabinet in the back, you had ride control system in the first couple panels, power distribution, relays, PLCs, that sort of stuff in there. And then the last couple cabinets were all drives. Ours was an older system. It used a Typac brand drive, TYPAC, Typac brand drive, and it used 4 of them, 1 for each motor. The newer upgraded models use 2 drives, 1 per pair of motors. So both motors that were turning counterclockwise, they got 1 drive. Both motors turning counterclockwise, they got the other drive. So you had 2 drives working, as opposed to the older ones, like the ones I was used to, had 4 drives sitting inside of it. So the drives were tuned, and they're very, very touchy. Everything affects these things. The motors, the brush condition inside the motor had a lot to do with it, how much torque could be transmitted through there, how much power was being lost. If you hadn't cleaned the carbon out of the brush area in a while, it would start doing all sorts of funky things. But basically the drives were tuned to be very reactive, and the current and torque settings on them were very, very fine. HUSS left a little thing that says like this is where they should be set, but then they didn't document a lot of other parameters. That I think they were supposed to be done like field documentation, which we never got. Like, okay, I don't see the field documentation anywhere. Wasn't there. So I was like, okay, so some of them were left up to us to try to figure out on it. But basically, the motors, when you use 2 motors back to back with each other, and you say we're going to turn one thing around, one's basically pushing, one's pulling. They have 2 different settings for it. And if you get the settings off, they start fighting with each other. And then you start, this pair of motors on the left side will start fighting with the pair of motors on the right side. And then the ride starts doing all sorts of weird things. So the drive adjustments are super critical on those things. They need to stay right. Automatic operation for the top spin. Typically what it would do, when you start the cycle, it would bring the gondola backwards up towards the back of the ride. And if you looked at the arms from we'll say from the right side, if you looked at them from the right side like that, the gondola would rotate all the way back up until about the 2 o'clock position. When it was at that 2 o'clock position, it would then lock the brake on the gondola. So the arm and the gondola were locked now. So this is level, and it would keep it right there at that position. And then it would start to rotate that arm back around and back underneath. And remember, the gondola is still at this position, but now you're pretty much upside down as you're going around. And then as it brought it back around, right around the 10 o'clock, right around the 11 o'clock position, if you're looking at it from that direction, it would suddenly then unlock and then power forward quickly. And then when it would unlock and power forward, it would get the gondola to flip over, and then that arm accelerating forward suddenly have to slow down, and then it would cause it to flip again. And then it would, as soon as it started flipping over, it would accelerate again and flipped over again. Now, I know a lot of people are like, okay, so how many spins would it do? The spins were dependent on the loading of the gondola. There was no set number. Nothing is driving the gondola. It's just gravity. That's all it is. It's just gravity and feedback of those drives. So if you messed with those drives just a little bit and affected the torque, if you made it just a little bit more torque, it would flip more. You can go 3-4 times over. If you took the torque and turned it down just slightly, it wouldn't spin over at all. It didn't have enough torque to move fast enough. So it was an incredibly dynamic setup that operators, they would sometimes call down, because ours on average had 3 spins it would do. It would go 1, 2, 3, and then it would keep going around. Operators would call sometimes and they say, it did 2 spins, so they shut the ride down. And it's like, there's nothing we can do about that. That's just how the ride is, how the loading is. Sometimes we get the opposite call. They say, it did 4 spins. They shut the ride down for that. And it's like, 4 spins? Hey, that thing's doing good. Let it go. Let the thing go. 4 spins. People are having fun on that thing. Come on, let it go. But it was all done through the dynamic drive tuning in there, because once it went up to those positions, the computer told the drive to accelerate and deaccelerate in these certain areas, in these certain windows, as it was rotating around. Between this degree and that degree, it wanted it to speed up. Between this degree and that degree, it wanted it to slow down. All that sort of stuff in there. But it was all those parameters times 4 drives working dynamically with the load in the gondola is all the stuff that would make it actually do the top spin. It was an incredibly complex process, and if anything is off inside there, it doesn't do it. So it's like, ooh, it was, if we had to make drive repairs, especially when we started losing firing boards and things like that, if you had to make drive repairs inside there, it was sometimes rough to get that ride back up to where it should have been, because you were not only balancing and tuning on one drive, you had 3 drives that were affecting how the one operated. That was really tough. It wasn't an easy thing. So once it started going through that top spin procedure, it was all just dynamic feedback from the drives to what the encoder was telling it to do, and so forth back around. And then at the end of the process, when it went to go home, it'd bring the gondola back around. It would go past, at the very bottom of the tower, there was a set of photo eyes down there that would look out at the gondola. We actually replaced ours from photo eyes to ultrasonic sensors because the photo eyes were actually facing the sun in the evening time. That wasn't great, so we had all sorts of trouble with that. During one point in time, during our haunt time of year, it was always like the ride wouldn't home properly for like a good half an hour in one area because the sun was just right. It was shining into the photo eyes, wouldn't do it. So we were like, okay, so we replaced it with ultrasonic sensors to where it still read the side of the gondola. We had to build a special homing flag over there so it could see that flag as it went by. But as the arms came down, it would see the homing as it goes by, and it would brake. It would turn the brakes on. It would start pulsing them as it was doing this homing process, because the gondola a lot of times is still swinging from the cycle, still swinging back and forth. So as it brought itself down and started homing, as it came across that photo eye the first time, it would turn the brakes on and stop the gondola and then release them, and then turn them on, then release them, then turn them on. And by the time it did that like 3 or 4 times, gondola would be killed with energy. It would just be sitting there. And it would pass that photo eye once, one direction, and then it would come back and pass it the second time, the other direction, and then the third time it would just slowly creep down just enough, and as soon as the photo eye caught it in the center, it would stop and say, okay, I'm homed. Now that homing process took the arm's position, had to be straight up and down, according to the encoder in the center. Then at the top, there was a proximity sensor that had to be flagged that said the arm was physically straight up and down. And then the photo eyes had to be flagged saying that the gondola is in the right position. So otherwise, you could have the arm straight up and down, the sensors straight up and down, but the gondola could be upside down. And the ride would still think it was okay. So to prevent that, that's why they added those photo eyes to watch the bottom of the gondola to make sure it was actually down. And everything, 1, 2, 3, were all in alignment with each other. And then it would allow you to open the restraint. Okay, so that was operation of the top spin. It's very complicated. It was very dynamic. I'm sure the later models, they've come out and made it a little more bulletproof due to the way you could just program drives and stuff. But all those old drives I was used to working with were all physical potentiometers on circuit boards that you had to adjust to get things just right. It was kind of a nightmare to keep that stuff working in sync, in tune with each other. As far as problems with them, the number one problem we ran into with that ride was big guess all the time. It would go to do its top spin and it would register a restraint open when it was doing it, and it would lock the whole ride up there at the top position. Most of the time we had to use that evacuation or the recovery procedure to bring it back down to the bottom and manually let the guests off. Occasionally we would have a coupler on one of the gearboxes break, in which case it's like losing a motor completely because the motor's not attached to anything. In which case the arms start doing this because it doesn't have that feedback. It's missing a motor on one side. One arm tries to pull it down and the other arm tries to, but it can't. It doesn't have enough energy to do it. So that's when that drive shaft kicks in and starts to transfer torque from one side of the tower to the other side and starts to help bring it down. Well, the entire time the thing is just behaving like a piece of spaghetti in the center, and it's moving all over the place. That arm halfway up, or quarter of the way up actually, is hinged on the one side. Remember that hinge I was talking about? That's to allow when the arms do this number, if you think about it, the measurement between my two hands right now looks to be about 15 inches. But if I move my hands back together like this, that's about 10 inches. So it gets longer and shorter, longer and shorter. So because of that, the gondola can't get longer and shorter. It's a fixed length. That's the reason why there's the pin on the one arm, and that pin on that arm is allowed to go in to compensate for that. So when it does that, it moves really far to one side. Instead of trying to rip the gondola in half, it simply just folds that arm in a little bit as it goes up and does that. So if you think about that number, it's going straight and bending like that motion. The last thing that did it for ours, I was working there when ours got the last nail in the coffin driven in there, because we were deciding if we wanted to spend the money and do a sizable drive upgrade and replace it from the 4 tie-pack drives to 2 DC drives, but it was a lot of money. It rivaled the cost that they paid for the ride. So the management at the time was thinking they weren't going to do that. And then we got a call one morning. I got a call from the mechanic, and he said, "Hey, it's doing something weird. Come down here." So I went down there, and we'd run it around, and like it would go along just fine, and then it would go through, and then it would just start to like shudder. It was just like as it went through one area. And I was like, "What is that?" And he was like, "I don't know." So we went and inspected and did a bunch of other stuff. We couldn't operate the ride that day because it was weird enough to where we said, no, that's not going to operate. It wasn't a minor thing, it was something bigger. We dealt with it for a couple of weeks trying to figure it out, and I think a week turned into a month. And operations, no one was on that side of the park. It was a low throughput ride. Unfortunately, it was in a bad area of the park, and people just weren't in that area to ride it. So it didn't get a lot of people riding it just because there was hardly anybody there. But so operations, they didn't care that we left it down for that long. So we finally had a company come through, and they said, "Oh, we do really good with troubleshooting and vibration analysis." And we're like, "Hey, let me show you something." And we walked them out to this ride, and we showed them what was going on. We explained all the troubleshooting that we've done, trying to pinpoint where this shutter was coming from. And they said, "Yeah, we can come out." So we wrote them a PO, and they came out, and they attached a bunch of their sensors all over the ride, all over the gondola arms and everything, and they started recording. And then we started doing it, and we let it do its thing, a couple of cycles, a couple of rotations for them, and then we did some other stuff for them. They said they just wanted to see like a slow rotation forward, slow rotation backwards, and came back, and they said, "Oh, it was on the left side, the upper slewing ring, that was bad." And they're like, "It's metal to metal contact on the inside." They're like, "You can see metal to metal," or like the way the frequency is on the sensors when it goes back around. They're like, "It's metal to metal." They're like, "Ooh." So we contacted HUSS, but it was through there's a third party that they use in the U.S. to do all the repairs and things like that for big stuff like that, because that was honestly outside the scope of work that we wanted to do for that particular ride. And they said, "We need the slewing rings replaced, probably all 4 of them." And they said, "Yeah, if you need those, and you probably need the uppers, you probably need the lowers, we'd have to take this." For the traveling models, it's not that bad because you break it down anyway. It's like, okay, no big deal. Traveling models are great for making repairs because you tear them down constantly. Park models, it's a whole different story. that was in a hard access area of the park where we couldn't get a crane to sit there easy, and it was just really hard to access. So unfortunately for that, with the cost of the repair plus the low access, the downtime that was going to be needed, we were going to have to pay an outside company to come in and do it because it was just way over our scope of work. And then there was the possibility of once we got into it, there was going to be other problems and this and that. It sat there for a while. We said we weren't going to do it. And then a couple of years later, they made the decision to remove the ride from the park. So that was unfortunate. A lot of people at the same time, they're kind of happy once that thing leaves. But they were truly fun rides to ride. Like, they're very fun to ride. If I was at a park and they're like, yeah, we have a top spin here, it's like, I want to go on that thing. Those things are fun to ride on. Again, if you haven't been on a top spin, go ride one if you have the ability to, ever. It's also like a free fall. If you ever have the ability, if you're in one of the areas where one of the 4 existing free falls are, go ride on a free fall. Fun stuff, fun stuff. Okay, I think that's going to do it for this video. There's probably some stuff I forgot to mention in there. I didn't want to go into too many of the other models, like the traveling model, that instead of being anchored to the ground, it's on a trailer and it uses giant water counterweights on both sides to hold the thing steady. When they changed some of those models, they changed so drastically that I'm honestly sitting here going like, I can't really speak for that. I don't know what it's like to work on the water counterweight models because I've been told they're completely different from the park models like the one I had. And then there's also the inverted model, which is very common, not very common, but I mean, the inverted model is out there right now. It's in operation. The only thing really different with that is it has to have a removable floor because the gondola has to get down somehow. So it's got to have a floor that comes up and down underneath it. So that's just a little bit of added automation and safety to that thing. If you haven't already, make sure you like and subscribe. Do all that stuff downstairs. That does help me out. If you want to email me, go ahead. It's ryantheridermechanic@yahoo.com. And as always, make sure that you stay off the air gates. Otherwise, I'll come find you. Take it easy. Bye.